Okay, good morning, good afternoon, everybody. John Holland, Chief Development Officer of Pinchin, calling in from Vancouver this morning. Thanks to all of you, thanks to the panelists, and thanks to all of you for attending our webinar today, and a very topical subject for me, at least, in Vancouver. Our subject today is building an infrastructure resiliency and the risks of overland flooding. This webinar is part of a series we presented since the onset of the pandemic on topical issues to our clients in the wake of the pandemic and just generally in the way the world's changing. We feel this is a good way of sharing our lessons with our community. We generally bring in a guest speaker, in this case, Dr. Sarah K. Khosravi from the University of Waterloo, and our very own practice leader, Gord Rajewski, calling in from Edmonton. This is the second day of our series on building and resiliency. We did one previously earlier in the year where we covered the issue of risk mitigation, risk management. That is how insurers look at building resiliency from a point of view of insuring an asset, and how potentially one of the impacts on a property's value will be its insurability and therefore its ability to attract financing capital. To extend this, we're talking about the issue of infrastructure and how, as our urban infrastructure grows, becomes more complex and puts more strain on existing stormwater drainage, how that will affect the values and the buildability and the durability of our urban infrastructure and buildings. So we have two speakers today, as I mentioned. Dr. Sarah K. Khosravi, I hope I pronounced that correctly, who is a postdoctoral fellow at the University of Waterloo. Sarah has a water resources engineering PhD from York University, and she has several years of experience working in consulting companies in urban drainage projects. Her very specific interest is in hydraulic and hydrological and water quality monitoring of watersheds, particularly in urban areas. She studied hydrological behavior of urban areas under climate change and urbanization, and has suggested global solutions using sustainable development techniques to mitigate the impact of overland flooding. In her current project, she focuses on the development of integrated modeling and DSS framework to attenuate the impact of eutrophication, which is the effect of excessive nutrient runoff into water bodies like lakes caused by urbanization, which causes more density in plant growth and a negative impact on fish and animal life in lakes. This is specific to Western Lake Ontario's littoral zone. In lieu of a fee for today, Dr. K. Khosravi has kindly donated an honorarium for Save the Children. So thank you very much for that kind donation, Sarah. And our second speaker following Sarah will be Gord Rajewski. Gord is the National Practice Leader in Building Science and Sustainability for Pinchin. He has a diploma in Building Construction Technology from Northern Alberta Institute of Technology, and he's also a registered engineering technologist. Gord has more than 35 years of building envelope and roof consulting experience, and has undertaken projects throughout Canada, the US, and even one project in Africa. Gord's experience in project management, project administration, reporting has made him a valuable addition to our group, and he provides senior oversight of all the building science work throughout Pinchin's practice groups across the country. So with that, I'd like to thank again all of you for attending this series, and I'd like to pass the webinar over to Sarah for her slides. Thank you very much.
Thank you, John. I don't see myself. I'm not sure that if I'm connected well. Do you hear me? Do you have my voice?
We can hear you, Sarah.
Okay, that's good.
There you go.
Awesome. Hello, everyone. Thank you for attending this webinar. I guess that John introduced me better than I could. At the moment, I'm working at the University of Waterloo as a research scientist. So this is my contact. I would be so happy if I could answer any of your questions later on regarding this webinar. I think that something is wrong with my video. I'm not sure. It's just my voice. So The outline of this presentation and talk that today we are going to have is like, I will give a brief introduction about what flooding is. And following that, I will talk a little bit about urbanization and climate change and its relationship with flooding. We will look into some solution that we could do in the future to prevent further flooding. And then we will have a sneak peek to one of my latest research in this regard, and then conclude all these talks. As my first slide, I would like to talk about flooding itself. And this slide literally want to say how risky and dangerous flood could be and has been so far. All we know that, like the other natural hazards, flood has detrimental effect on our quality of life. So it has caused lots of casualties, financial losses, and deterioration of the ecological system, environment, both in worldwide and also in Canada. Let's have a look at the World Bank report. It has been studied during 2 decades from 1995 to 2015. In this study, it has been reported that the proportional flood among all natural disaster has been the highest with 43%. And that is a big percentage for different kind of natural disaster. It has caused 157,000 of life losses. It's like more than a war. So it wasn't only life losses, it has affected 1/3 of the Earth population by 2.3 billion people. Also, it has cost about 50 billion USD during these 2 decades of study financial losses. And that could be, I guess, around 50% of Canada's government's revenue per year, right? And one last bad news is that this trend has been increasing during that last 2 decades of study. And this trend shows that it is increasing in the future. So the risk of flooding is increasing in the future. Before that, I get to the other slide, I want to distinguish between different types of flood, specific in the urban areas. When we think of flood, usually what comes to our mind is river flooding. So rivers runs, and when there is a rainfall, it's okay. When it's like a more rainfall and extreme rainfall, the river plain expands and it can drown the surrounding neighborhood and those that are close to the river embankment. And while we are calculating the risk of flood, we calculate that floodplain. But there is another type of flooding in urban areas that we might neglect usually, and that is plovial flood, which is as important as fluvial flood. What plovial flood is? It is a flood that is related to the stormwater collection networks. So in the urban areas, the runoff and rainfall doesn't convey to the downstream only through the river. It conveys through the stormwater collection networks, which are pipes located underground and collect the runoff and just discharge it somewhere downstream in some water bodies or lakes or somewhere else. When these pipes are at lower capacity, they could be dangerous as rivers. So in manhole pipes, which is the connection of 2 pipes, the water can go out and put us in danger. I'll bring this, I want to display one video about the Plovial Flood, which is a flood from the one manhole in here. And it is a footage recorded by a highway camera. Oh, sorry. I should make sure. Sorry. No. Okay, now it's displaying. Is it playing for you, the video?
It doesn't appear to be playing.
Yeah. How about now?
It's playing now.
Okay, sorry about that. Yeah, this is one of the extreme manhole flooding that has been observed, like recorded by air footage. So imagine that if it happens around your property or in your house, or you were one of those cars. We know that like the flood is growing and it's intensifying in the future. And I talked about that this grows and this trend continues in the future. Why is that? There are some drivers for that. So the first driver is the urbanization, which is the expansion of urban areas. And we affect the increase of flooding in two ways. One is that with urbanization, we change the land terrain, we change the slope, we pave every soil surfaces with asphalt, with concrete, we change the vegetation cover, and with that, we change the hydrological behavior of the area. So meaning that when there is a rainfall, because we have paved the soil and all pervious surfaces, all that rain remains on the surface and becomes runoff. And that runoff, if we cannot collect and manage that runoff, it would be a flooding at some point within the urban areas. In addition to that, there is a increase of concentration of population in urban areas. And with urbanization, building cities, we concentrate population and our properties in a specific and limited area. So when flooding occurs, because the concentration is high, the loss of human lives and properties would be higher. We have another important driver, which I'm sure that you have heard of before, and it's well known, and that is global climate change. And how it affects flooding, we know that climate change increases the temperature, and that increase in temperature increases the rainfall. An increase in rainfall will lead to extreme floods, because after high rainfall events, we will have higher runoff, and that runoff, as like I explained, remain on the surface and becomes flooding in the rivers and become flooding in the pipelines. Let's have a look at the hydrological cycle of like if this is like a simplified schematic of a hydrological cycle of an area. So with this hydrological cycle, we know that the unique hydrological regime of an area comes from different factors. One is the climate, and the other one is the vegetative feature of that area, and also the slope and topography of that area. So with urbanization, we change one of the factors, which is two of the factors, which is vegetative features and also topography. With climate change, the one other factor has changed. So in all, we will see extreme rainfall and also higher amount of runoff remaining on the surface. What we can do about it? One traditional approach to manage the extra runoff, like I explained before, is stormwater collection networks. What these networks do is that just they collect runoff from the surfaces through the inlet. Probably you have seen one in front of your house, and like if you look closer into the street, you will see these little gates that just when it's raining, the runoff goes into them, and these runoff will be carried out to the downstream, and they will be discharged very far downstream into some natural streams, also maybe into some stream stormwater treatment plant or some designed location. However, these stormwater collection networks, or CNs, has been designed for years. It has been like from the ancient years to now. They're well known, they're well documented, but there are some limitation and problem with them. And I just point out some of these limitations. One is that they are pipes, and they have been designed for limited capacity. So when we have extreme rainfall, they cannot convey more than what they have been designed for. And that is one specific problem due to this, related to these SCNs. With age, these pipelines can have cracks, can be deteriorated, and also they're aging. So with those aging, they may encounter limited capacity, like blockage, sedimentation. All those aging problems can lower their capacity. Also, one environmental challenge with these SCNs is that we know that in the surface of the urban areas, there are polluted pollutions, and with runoff and rainfall, those pollutions, like from car grease to many other pollutions, fertilizer, everything, they can be washed off and collected through these pipes and go and discharge into some streams. So that is one other critics toward these kind of networks and so other management techniques. And on top of that, for building these pipelines, we are using environmentally unsustainable material. Usually we use polyethylene pipes or things like that. The question is that what we can do to assist these networks. They already exist. We don't want to just rip them out and just start off with a new approach to manage runoff. They already exist, but now we are aware of that they cannot manage future climate change. They cannot manage future developed and extreme sprawl urbanization. What we can do to help these? Can we build lots of these stormwater collection networks? Can we add more and more pipes? What would be the smart solution to help runoff and flooding management and preserve the environment at the same time? So like I explained with the urbanization, there is like with the natural status of the environment, when there is rainfall, there is soil and it's pervious and it's just filtered to the underground. The rainfall filtered to underground. With urbanization, when there is rainfall, we could see that we prevent infiltration process, that natural process. So all rainfall will remain on the surface, or most of it. What we can do, there is a solution called low impact development, which is lowering the impact of development or urbanization through some engineered infrastructure, green infrastructure. And this is a sustainable technique for runoff reduction and wants to imitate the nature like before urbanization. So we just build some infrastructure, which mostly are green, and capture the runoff and infiltrate the runoff into the ground like it was before. And it has been proven scientifically that it can effectively capture the runoff at the source, so it doesn't allow the runoff to be accumulated and go into the pipe. Then pipe has low capacity and we experience flooding. Some example of LID or low impact development are shown in here. When I show these example to you, you may have seen many of them around your area or around some workplaces. For example, one is the rain garden. They are designed to capture runoff. They may seem simple, but they have some designing criteria and engineering calculations. So there are some examples in here: infiltration trench, green roofs. Probably many media has covered green roofs in some videos or photos of it. Porous pavement, which can infiltrate pavement, infiltrate water into the pavement, the groundwater. Also grass soil, landscape, water bodies, and so on and so forth. One thing that I want to mention is that these LIDs or LID techniques are the solution after that urbanization has been done. And one key point that I want to stress on now is that before that we start development, we can do a lot more to prevent runoff, to prevent flooding. And that is non-structural measures of low impact development. So these were structural measures after urbanization. Those non-structural measures includes lots of measures that we can conduct during the urbanization, during our development, to lower our risk and society risk to the flooding. And I brought some example in here, like conserving natural resources and ecosystem through maintaining natural drainage courses. We don't construct over the natural courses or very close to them, and just preserve the natural courses as they are. And reducing imperviousness. So let's say that we want to build a parking lot. We reduce the imperviousness as much as we can by narrowing the width of that parking lot and just leave the rest as soil or as other pervious material. And we could reduce the use of pipes. So for example, we could connect our rooftop to the one rain barrel. We could use the water from that rain barrel to water our garden, and at the same time, we have prevented the output of that flow to the entering to the pipelines. And minimizing clear and grading in the development process. So whether to preserve the slope of the nature as it is, and stuff like that. So there are lots of measures that we can take to preserve flooding and runoff while we are developing and do the development. And this is an interesting part, that this LID techniques do not only serve the runoff reduction, they have lots of more benefits. The primary benefit could be runoff reduction, but there has been lots of studies showing that LID have positive effect and have positive socioeconomic effects around the hospital, around the educational institutes. They have been proven that that LID can improve health status of the patients, can improve the educational outcome, and it could be considered as an amenity, right? So could be a golf course or could be a green space for us. And it can increase the value of the properties around them. Also, it comes with lots of environmental benefits. These environmental benefits are numerous. I just listed some of them in here, like they could decrease the air pollution, also help the water quality. Before that, the one that I mentioned, that the stormwater collection network collect the polluted water and just directly discharge it into the water bodies. But with the use of LID, you could just have an infiltration of water and improve the water quality. And it can affect the biodiversity, connect the biohabitat, and benefits like that. So now that we know LID has several benefits, and we know that when we want to build something, build some infrastructure, we are limited into the budget. So we need to make a decision. We know that there are multiple types of LID. At the same time, we have multiple locations that we want to implement and build LID in them. So we need to think what type of LID we need to use and at which location we better to implement LID to maximize all these benefits, to maximize social benefit, economical benefit, environmental, and also capture the runoff the most. I have done it through one research, and it has been published in the Water, and that is the link of the paper in the title of the paper if you're interested in. So in that paper, we answered that to prevent flood, if you want to implement LID, we wanted to create a map for example, for the city of Toronto, which were our case study, we want to generate a map that gives us the points that has the highest priority for LID installing or building. I think that my computer has frozen a bit, sorry. So this is the city of Toronto. This is a map that at the end of the research, we finally generated. How we came up with this solution or with this map is interesting. And I guess that could change your view about how we decide about where to implement LID and also all those measures that you need to take. So to generate such a map, we divided this big problem into three. One, the hydraulic benefit of LID. We generated an index for that, socioeconomic benefit for LID, one index to indicate this criteria, and also another index, which is a map that indicates the needs for environmental benefit of LID. So it has been overlaid and done through different mathematical calculation, and we use geospatial information system integrated with multi-criteria decision-making framework to come up with the answer. To generate these three indices, sorry. To generate these three indices, for each indices, we considered some basic criteria. I'll give you some example. So for the hydraulic index, we gave priority to the locations that has the, for example, lowest hydraulic conductivity. What does that mean? It means that the locations that infiltrate water, the rainfall water, the least. And also with the highest slope, which slope is a factor that can increase the risk of, increase the peak of the flow when it is a rainfall. An example for socioeconomic is that, for example, we wanted the green infrastructure of LID to be close to the schools, to be close to the hospital. So we gave priority to those locations or where we have less green spaces. In terms of environment, we gave priority to locations that have higher air pollution, has lower biodiversity, and criteria like that. So these criteria are very case dependent, but these are some examples that can give us a view that how LID can serve environment, social society, economy of the society, and also flood at the same time. This is only the hydraulic index, which is only flood related factor. This map shows the city of Toronto. I have highlighted the top 2.3% ranked sites. So these sites are the sites that are priority for implementing LID. And it means that when we have this much sites in Don River, and this much site in, for example, Mimco River, which is very less, the meaning of this map is that in Don, we are in need of LID very much more than Mimco. So there are lots of sites that need LID in Don because the runoff generation in Don is much higher than in Mimco, for example, and also in Humber. And our statistical analysis shows that too. So if we look at the index and distribution, we could see that in the Don watershed, we have a very high need for LID, like the graph is higher, has a higher mean. And also, like if we ranked all these watersheds that were located in our study area, and we could see that Mimco has the lowest. So Don and Humber are more critical in the city of Toronto in terms of runoff generation, and they are more urbanized in that sense. And this slide brings me to the end of my presentation. And I just had a few key messages from this presentation. I want to deliver these key messages. And one is that if you're afraid of river flooding, be as afraid as in like manhole flooding and basement flooding. They're equal. So if we have extreme rainfall, the possibility of flooding in both are not are the same. Also, in LID can reduce the risk of runoff in urban areas very effectively. Take it serious, and that is a very important and effective solution. And remember that it's not just serving the runoff reduction and flooding, it is serving the society and environment at the same time. And also during the development, before that we have started the development and started the urbanization, I want you to think of preserving the nature. That could save a lot of resources, a lot of financial resources, and prevent lots of flooding. Thank you. And I would be so glad to take any question if that is the question time.
I think we'll go to Gord's presentation, Sarah, and then we'll do questions at the end. That's okay.
Okay, great.
Great,
thank
thanks.
you. Thank you.
Over to you, Gord.
So what we're going to do now is we're going to carry on from Sarah's presentation on overland flooding and some of the considerations around our sites and our buildings. And we're going to follow on with a little bit of discussion around buildings specifically. So if we can advance the screen here. So today we're going to talk quickly about sustainability versus building resilience, climate change and infrastructure risk assessments, trends in resiliency, design strategies, and a roadmap. And we're going to leave you with a few resources. So what we do here at Pynchon is understanding that climate change is real and the impacts are many and can be dangerous. We try to assist clients and with the process for how do they better understand the vulnerability and the risks that they have. So we often consult with clients who are wanting to get started in the process of understanding where the risks may be. Before we get into that, we need to understand that our definition of resilience or resiliency is if you can create something that's durable, add to that with some sustainability in mind, you will ultimately become resilient. So it's with that perspective that we're going to give our presentation. So Sarah's talked a great deal about overland flooding, and what we want to do now is introduce you to what we call the infrastructure risk assessment. So what's the process for discovering where your vulnerabilities may be with respect to things like overland flooding? What's the process? Risks are why we do this work. Many codes are based on historical data and do not reflect future risks, including the impacts of climate change. Sarah mentioned that existing infrastructure that's been underground for stormwater management has been there for many, many years, and it may no longer be sufficient to handle the future capacity required or the future volume of water that may be a result of climate change. When we look at risks, we're looking at beyond flooding, we're looking at the interior of the building, the mechanical systems. Stormwater management systems may not have the capacity to drain sites. We also look at things like the roof on the building in terms of whether or not the roof has capacity from rainfall in the volume that might be forecast in the future. We look at the way water can be prevented from getting into the building. Whether it's from wind-driven rain or from flooding. We look at from flooding and sea level rise and the impacts that has on the building structure. So flooding and sea level rise can scour the structural elements, causing weakness And then when there's been flooding and that's caused impacts to the grid and the ability of the municipality to produce power, that can result in problems for continued operations. So let's talk a little bit about infrastructure risk assessment. So there is a protocol that is followed. One of the protocols that we use is called the Pivc Protocol, which is developed by in concert with Infrastructure Canada, the federal government. So this is currently sponsored by the Climate Risk Institute. It's done in conjunction with ASTM guides for climate resiliency, CSA guide for durability, ISO 14091, and it fits and is in conjunction with BOMA BEST, GRESB, Fitwell, IRM LEAD, and Climate Lens. So a lot of these different terms you may be familiar with, but essentially this is the starting point for understanding where your vulnerability may be with respect to your infrastructure from climate change. The risk assessment basically defines the why. Why are we doing this? Well, we want to avoid the effects of overland flooding and other such effects from extreme weather. So that's the why. The next part in the process is developing a risk profile for your site. We do this in conjunction with climate modeling, climate science. We pick a site and time horizon. So we take the physical address of your infrastructure, and then we apply climate science modeling to that. And out from the output of that gives us information on where the greatest risks may be in terms of future climate change. The next part in the process is we will then gather data with reference to your specific infrastructure. So what kind of building, what kind of site do you have, what exists? We look at the plans and the designs and the current operating features of that property. And then we create a risk analysis, which is involving risk tolerance. We involve stakeholders in a facilitated workshop, and we come together and determine which things we should focus on. If required, we will also do some engineering analysis to determine the capacity of the infrastructure to tolerate what we see in the data. And then we prepare a report which provides conclusions and recommendations for management, adaptation, or mitigation. The fundamental part of that process involves creating a heat map. In this example, this is for a healthcare facility, and all such heat maps in these assessments look something similar to this, where on the left side we have the severity of occurrence, and on the bottom we have the probability of occurrence. So we take a look at each infrastructure system, and we apply a scoring from 1 to 7, and 7 being a severe, an occurrence being quite severe. And then similarly, we do that on the probability side from 1 to 7. The higher the multiple, the greater the concern. So if you've got items that show up in the red square area, these are areas of further focus from a recommendation and mitigation standpoint. So here's an example of what we do on the mechanical side. We basically look at the infrastructure and make an assessment. We create the heat map based on the workshop and the data gathering, and out of that we arrive at the scoring that you see. So just different examples, and then ultimately we create a report with recommendations. So the output of that assessment provides the conclusions. The conclusions will say that your site may be vulnerable to overland flooding. And then we have to decide with the client how best to respond to those conclusions. And so this is where we get into implementing adaptive measures. Once we have the basis of understanding of where the climate risk is, it becomes an engineered project, if you will. So we have to create the design, we follow the tender process, and then we get it built and we commission it. So, but the first part to that is understanding where the risks are. So here's some trends that we're seeing in Canadian facilities. This is what owners of infrastructure are thinking in terms of climate change currently. They're looking at distributed energy resources for information systems. So the impact of climate change is such that being able to maintain your information systems in times of extreme weather or currents is critical. Obviously, power failure is a big issue. So if your hospital, for instance, were to suffer a flood and that impacted the ability of the grid or even the building itself to generate power, what would that look like to the continued operation of that particular facility? We are also considering other things like seismic resilience. And then the other thing that's become quite apparent in Canada is that building codes are not keeping up to the impacts of future climate change. So working together with government, both in federal, provincial, and municipal, to ensure that the building codes are keeping pace with future climate change. So Sarah mentioned low impact development. So having the capacity within code to ensure that future development takes this into account, making sure that we're doing what we can in advance of what climate change forecasting is telling us through code. Here's an example of a brand new building. It's a hospital in Mollet, Spain, where the design of the building takes into account all sorts of different aspects that involve both sustainability and resiliency. So nothing specific to flooding, because that wasn't a big concern in this particular area, but here's an example of how new design is being modeled around the subject matter of climate change and adaptation. Here's some of the things that is being done in Alberta with reference to healthcare facilities. So these are some of the things that they're looking at, but they're not looking at the fulsome picture, if you will. So resilient design strategies, as Sarah mentioned previously, must take into account from the vulnerability assessment how best we can prepare our infrastructure for the future impacts, whether that's through the building envelope, whether that's through the site characteristics, the site designs. How are we planning to continue to operate the building during adverse weather, through extreme weather and such. So incorporating different features in the design and planning of the infrastructure in response. So this is an example of a brand new development, but it could be for buildings that are already in place. One of the key focuses is making sure that we are able to continue to operate should the grid go down. If the site area is flooded, if the city becomes flooded, how can we continue to operate under these extremes? Some of the design features that are cutting edge for buildings around this subject include incorporating things like building integrated solar technology or photovoltaic cells in the cladding and the roofing. Basically, in a nutshell, if we can harness the power of the sun to help operate systems within the building during situations where the grid may be compromised for temporarily. It will allow us to survive those impacts longer. Modeling for future weather. Here's an example of a requirement through an RFP from a healthcare facility or healthcare provider in the lower mainland of British Columbia, where they're asking designers to contemplate future weather in their designs. So we're seeing more and more of that. Maximizing daylighting. These are part of the resilient design principles that we're following, where we're basically saying that resilience has to transcend scales. Resilient design incorporates and protects natural environment and resources. It anticipates interruption and adversity. It involves simple, passive, and flexible systems using durable materials and systems. We try to incorporate locally available renewable resources, and we have an abundance of diverse and redundant systems. Sarah mentioned issues with current municipal stormwater management. What we have come to understand is most municipal infrastructure is currently not designed for the kind of outflow from sustained rainfall, for future sustained rainfall. So some of the things that we are thinking about is there an opportunity to store rainwater on top of things like the roof of your building or on your site? So in this schematic, we're talking about something called a blue roof, where the top of your building, your roof, if you will, could be used to store rainwater longer, and then take that stored rainwater and distribute it in a managed way so it doesn't overwhelm your stormwater system. And perhaps the water that's being collected can be used elsewhere for site purposes like landscaping, irrigating landscaping, and running gray water systems in your building. So this is an example where we're trying to say perhaps the municipal stormwater system will not be able to be upgraded in time for what future climate change is predicting. So is there an opportunity to look at features like the roof of your building to protect the site from being overwhelmed? We also get into things like wildfire mitigation, which isn't really the theme of our talk today, but using fire resistant materials and keeping smoke from getting into your building, looking at different features to protect the building enclosure. Getting back more on the stormwater side and overland flooding side, here's an example of a design institute in California, which has been designed with overland flooding and extreme weather in mind. As you can see from the photo to the left, the building has been created such that as sea level rises, as overland flooding may occur, the water will be able to run through the bottom of the building without causing any interruption to that building and the occupants inside. Other elements are protecting the critical systems inside, hardened ductwork and such well inside the exterior envelope of the building. But just by designing the shape with the anticipated sea level rise or overland flooding that may come, we're anticipating that this could be an issue. And so we're protecting the building and its critical elements, including the occupants, from that eventuality. We know that when we get severe rain, we also may have hurricane-like winds. So strengthening the building in places in North America where we typically did not have to think about these things to the extent that we do now. So here's some examples of strengthening the infrastructure against extreme weather effects. And considering different shapes, we know that if high winds are an issue, trying to create shapes that will be more resistive to the impacts of tornadoes and high winds, where overland flooding isn't as great a concern, locating infrastructure below ground. In the example to the right on the screen, this is a hospital that was constructed in Boston, Massachusetts, where they anticipated, because of the location of that hospital, that there would be concern from overland flooding. So in spite of what you see, the building to the right has been designed with overland flooding in mind. And again, all of the critical elements that are necessary to operate that building are located well above grade level. But the building on the right has been designed with overland flooding as a prime consideration of climate change. So our journey map to resiliency at Pynchon looks something like this. We must first consider what the risks are. So the why. Why are we doing this? What should we be concerned about? And then we help create a roadmap for clients to help them better understand how to adapt and to introduce mitigation against those climate change effects by doing an infrastructure vulnerability assessment. Then we can assist by providing design and tendering and construction assistance towards mitigation, commission, and then re-audit. The last box there, the re-audit, is an important consideration, as what we know or believe may occur today is going to be ever changing. We don't know for certain what the extreme effects of climate change might be in 10 years from now. So it's important that we periodically revisit conditions so that we put our clients and our people and the safety of buildings and people first, and we're making sure that we are as prepared as possible for what may come. Some resources. Here's some examples from the healthcare side, where there are guidebooks now on design that are out there. The Healthcare Facility Climate Change Resiliency Toolkit. So here's an example of the healthcare industry providing a toolkit to help operators of healthcare facilities be prepared for resiliency. The International Federation of Healthcare Engineering has many great papers. Sarah mentioned that schools and healthcare facilities are prime objectives in the protection and the design for the impacts of overland flooding. So the International Federation of Healthcare Engineering is a leader in this area, and they've provided many papers and great information. For those of you that want to know more about what we're talking about today, the Climate Risk Institute works to advance practice and deliver services related to climate change risk assessment, adaptation planning, and resiliency. So there's some information for you. And that concludes my portion of our presentation.
Thank you, Gord. Thank you, Sarah, for two excellent presentations. There was a question that you've answered online, Sarah. Maybe you could expand it a little bit for the audience. It was a question from somebody in Northern Canada who asked about being able to apply LID in northern climates where sand is used extensively and potentially, I assume, blocks up drainage infrastructure. Could you maybe expand on the answer there, Sarah, a little bit for the benefit of all the audience?
Sure. Thank you, John. Actually, I want to first explain that LID has been around for like less than 2 decades, so it's so new. So design of LID has been challenging during these last decades that it has to come to be used a lot more. And like optimization of the design of LID is still a question for scientists, and still lots of work on it, specifically in the cold climate, because that is not a regular climate. So just countries that are located in cold climate are interested in those kind of research. But there are different options of still we don't know that much about the like optimized design of each specific type of LID. But still there are guidelines in Canada specifically. Each province has developed their own guideline for designing LID, even the northern region. And based on those guidelines, these design and optimized design has been considered. One alternative option for those sands that can be clogged is that if we are considering those type of LID, the operation and maintenance of that type of LID can be reconsidered and can be optimized for that location. Another thing is that maybe that type of LID is not the proper type for that area. So the type of LID can be changed. There are alternatives for sand type like cisterns that can just collect the runoff, or maybe grass soils that can just convey the runoff and doesn't need to infiltrate the runoff. It attenuates the runoff, gives the runoff a little bit of infiltration, but it just delays the runoff to join the other runoff in the downstream and create chaos and flooding. So there are multiple options, like considering the optimization of design, considering alternative operation and maintenance, and alternative LID types.
Thank you, Sarah. Gordon, question for you. When people are renovating, which our firm gets involved in heavily with clients doing localized repairs, my guess that's a good time, especially if it involves groundwork like drainage, roads, electrical or power infrastructure. You don't have to do a complete revamp of the structure to make yourself more resilient. There are short-term fixes you can do. Have we been called, or is that something that we can help clients with?
Certainly. We are in conversation presently with one of the largest real estate developers and portfolio owners in Canada at the moment. And one of the big questions that owners of infrastructure in Canada have is they're still trying to come to grips with what is being presented almost on a daily basis in terms of the challenges that are impending. So how do we implement mitigation and adaptation measures without causing bankruptcy? So what we do is, in a common sense sort of way, we work with owners to help develop and build resiliency into their buildings, but do it in a way that we can manage that cost. So for instance, if there's a contemplated renovation, perhaps it's of a roof, and the roof is flat. If we know that we need to be concerned about heavy rainfall in the future, that might be the time to add additional drains to the roof, to incorporate things like site cisterns where more water can be stored and managed. We might also look at the landscaping, the hardscaping, the landscaping, and introduce further collection of water on the site. Some of the things that Sarah spoke to. So the message is simply this: we don't know fully what the negative impacts are going to be in the future. What we do know is that we have to get started now, and there are some things that we can start doing right away. And there's some things that we're going to have to incorporate as budgets allow, because someone has to pay for it. And so Pynchon works with clients in an orderly, common sense way.
Okay, thank you, Gord. That's thank you for that clarification. Okay, we are perfectly on time. So with that, I'm going to close the presentation with a big thanks to Sarah, Gord, and Kaylee for organizing, running, and delivering this. That was an excellent presentation. We do like your feedback. You could scan the QR code on your screen now and tell us how you found this presentation. That helps us calibrate your appetite for future subjects and things you'd like to hear about as part of our service to you. So with that, I'd like to close the presentation. Thank you all. Thank you for attending, and wish you all a good, safe day. This presentation, by the way, like all our practice innovation series, will be available on the Pynchon website for viewing later. People would like to recommend this to their colleagues or review what we presented. It is available. Big thank you to all of you. Have a good day, and we'll talk to you all soon. Thank you very much.